All right, so yesterday I had figured out some of, I guess it was like right after work, I sat down, stood up, wrote on a whiteboard, sort of like designed what this entire thing would look like. So if I switch over to my whiteboard, this is the drawing that I got up and going. So the big thing here is I realized that I need to extend the grid all the way out. So that would be the entire world. Currently, the way that it's working is that the grid is only on the screen. And so anything that's outside the screen, there's just sort of like one extra band, and everything is out there. But if I have the grid last the entire world, then I could have the camera move across the grid, and then all these static objects in here, they just stay in their specific grid point. So I'm not going to have to worry about it. And then the only things that are actually moving then would be the camera that's panning to the right, and also the player that's moving to the right. And so the player could be switching grid locations, and the camera probably would be outside of the entire grid area, and then it would be querying the grid and saying, hey, here's the coordinates that I have. Starting with 0 to here, of course, we're going to have to add from the start of the grid. So 0, 0 plus, I guess in this case would be 50, to whatever the screen width is, plus 50, screen height plus 50. I guess not screen height, that's not really changing. But then I would just say, hey, give me everything that's in there, just put references to it in an array. And then I'll go ahead and loop through them and run the drop method. And that will be the camera. So I think that's going to work for us, but there's going to be a little bit of refactoring for us to do to get that working. So to begin with, I'm thinking that the grid here, we need to change this. So when we create our constructor, let's also take a look at game data. So we have screen width, screen height. I kind of almost want to switch this to a camera width, camera height, just to be a little bit more explicit. So camera width, camera height. Sounds like I got a good direction. Awesome. And let's see. In this case, we might want to make this more of a square. Maybe not. I don't know if it matters. But cell size is going to be really important here. Because now, instead of us trying to divide cell size into that fits into the entire world, none of this matters anymore. They're all going to be very separated from each other. Our floor, why this may not matter quite as much. We might be able to just say for right now, I think I can use that. But let's see, I think that'll be fine. Let's go back to our game. How do we create our grid? So we just do grid, new grid, game data, cell size. Okay, so if I do cell size, and the grid doesn't really care about anything, right? So we're going to come into grid. We get the cell size. Of course, this is default 100. Now we're going to get this horizontal count, vertical count. This is going to be very, very different now. We need to know what's going into this grid and how many, what the width is going to be for us. So we probably want to say world length, world width. If I say something like this is 1000 as a default, but in reality, the width is going to be the level dot length, whatever the length of this this array is. So let's go back to game here. So the second thing we have here is it's going to be the game data dot level dot length. And then that is going to let us create that sort of extra long grid. So horizontal count is going to be, now in this case, vertical count, I don't like, it's an interesting idea because I don't actually know if we need a, like this huge vertical count. I don't know if we need all the grid points above what, like I had 3. So we take a look at the whiteboard again. Above here, we don't really need to store the grid, do we? Now, if I later on decide to like add anything, I may have to like create some kind of like change the level so it's not just like a single array that represents this band, but rather like, you know, array that represents, you know, an array of arrays that's itself a grid. But I don't think that's a problem right now. And if we stay with our current plan, our horizontal count, we really care about, okay, so horizontal, vertical count. Oh, need to change back. Our vertical count is going to be the number of, I guess like it's a single dimensional array, right? So like the number of y coordinates in the game data. And we can put this here so that it's going to be like the world height. So if we do world height, and I say that this is essentially like 2. And maybe this would be like world width count. World horizontal count. And then world height count, vertical count. And so we say, hey, we only have like 2 things in here. Maybe we should just say, hey, by default, we're 4. And that kind of makes sense because I might want, jumping probably will bring the character into the third block square. Yeah. So I'd say 3. Now here in game, in this one, I know I just want it 3. I don't know how like I could possibly say that it is 3. Well, okay, we can put this in here. Maybe here we'll have world height is 3. Game data dot world height. That way, if I decide to change this later in data, then I've got that covered. Okay, back to the grid. So now we have the world vertical count, the world horizontal count, and that's like the cells, right? So this dot horizontal count is going to be world horizontal count. This dot vertical count is going to be world vertical count. We already have the cell size, and then we start creating the cells. Now we no longer need off-screen left or off-screen right. That's just not going to be a thing. And then far off-screen left, yeah, we still don't need that. That's not going to be a thing either. We're going to loop through, so that y count equals 0, y count is less than this dot vertical count, would count plus 1. Okay, so this is like up from like the top to the bottom. Okay, and I think this is still fine. Const y cells equals. Okay, so basically we create the each cell going down. So this is going to be only 3 of these. Then we create the X cells across the entire world. And so push that in, and that's still going to be an object. And I think this is still going to be fine. And then we push into the Y cells, and then we figure out what our line color is going to be for like drawing out the grid. Then we have this draw grid. Okay, so for each XLs. Now this is starting from like the very top, and I'm not sure that this is actually going to properly, I don't think this is really gonna properly show what the grid actually is. I would want to, for the grid, actually maybe draw a rectangle for its like position. And maybe that will like help us understand exactly where these are. So if I do, let's see, stroke, I think I can do no fill, which will make it so that it's not an actual like square. So that's white, that's fine. We're going to loop through each of the cells. We get the X cells and the Y index. And then we draw a line from, it's actually wait and draw a rectangle. So we'll have some overlapping lines, but I think that's gonna be fine for just drawing the grid. So we're gonna have X cells for each. We have the cell and we have the index. Okay, so we have both indexes. We know what the index, like the width is of each cell. There's squares, which is super helpful. We know we don't really care about the camera position. We're just sort of like overlaying this on the screen. And the next thing we need to know is where the like where we're starting. And look, it sounds like we're building from the up, like from up to down. So we need to know the beginning of each cell. And that will help us determine the math also when we do like adds. Like where are we putting stuff? So if I do, I guess I could start from the bottom. I don't know if I don't think I want to reverse the logic and have like, okay, position 0 is like, at the near bottom and then it goes up. Even though like on a graph, that's how it works. I kind of want to stay with how the pixels work with like going, 0 starts at the top left and then goes down from that. Which means I need a offset of how far down this world is for the camera. Ooh, interesting. Do I actually, I hadn't thought about like whether or not that's something I care about. Maybe this is like a premature optimization that I don't need to worry about, that I'm like making it too complex for myself. If I put it exactly back the way it was, I create like all those grids, all those cells, but then they're just not going to be, I'm just not going to really care about them. I don't know. Or our game world is just that small. Could be that. Let's say we go back into game data and we change our world height to, what did I have? It's 50. And I'm having my world. Wait, did I have this? Oh, I'm using screen width and screen height. I guess this is the world. Camera width, the camera height. This is going to be essentially, the entire thing is the camera, right? So this is camera width, camera height, and cell size. If I have the cell size match the same, the world height is essentially 50 divided by 500. 50 by 50. That's 10 of them, I think. So if we go back to this, then should be exactly the same as before. Can I do squares based on this and like understand, like actually have the rectangles draw in the appropriate spots? What would that look like? So rect. So in X, so we would start with the top left. That would be 0 times our X index. So it would not be 0, it would be our X index times our cell size. Then our Y would be the Y index times this dot cell size. Okay, then the width would be this dot cell size, and then a height is this dot cell size. Okay, I think that works. So if I don't do anything else, and I just do this draw grid here. So let's not throw this in here. Bear Duda, good morning. So I create my grid. We have our camera that I'm not going to worry about this right this second. I just want to create the grid and I want to draw the grid. That's all I want to do right now. Well, that didn't work the way I wanted it to. We have just purely black screen. Do I get an error? No error. Rect was expecting at least 3 arguments, but received only 2. Wait, is that true? In grid for rect here. Cell size. Wait, did I not store this away? Oh, I have cell height, and I never did this dot cell width, cell size. Yeah, I never actually stored these away. So here, this dot cell width, this dot cell height. Okay. Kind of accepts that. Let's take a look at let's do a debugger in here. And for this, let's hit refresh and take a look at what we've got. So we've got this dot, oh, this dot cell size. Wait, is that still cell size? You need to be this dot cell width, and you are cell height. Okay, I think that's gonna work then. If we press, let's remove that debugger. There we go, and so now we have our grid properly displayed for us. And so this is going to be the world. It's extending way farther out than what we have seen here, which I think is fine. Now we're going to have like the camera that's going to pan across it, but that's not going to actually have the grids move. I think the grids is just for us to like sort of see, hey, these are working properly. So we actually don't need to draw them. Okay, so once I've drawn the grids, the next thing is I want to add everything in to the appropriate spots. That's going to be this add here that we have again. So we're going to loop through the level information in the game data. We're going to figure out what is going into the cell, the index of it, and then we're going to build the level out. So basically run each of these functions. And for each of these functions, we're going to call, tell it the index, the X sort of horizontal position, the Y position that they're gonna go in. The Y position should not change at all. And the X position here should be fine. For cell size, that's still a thing, yeah. And then the grid. We pass in the grid, and that should add all of these things. Then I should be able to run draw. None of this should change, I believe. It should still add it into the grid here with add. Now, do these need to change? I don't think so, because we have the same number of grid things. We've just expanded this way off to the side, except for this entire off-screen left. This is going to be a problem. I need to make sure that we can handle all the way over to the right. So we're going to figure out the X index and the Y index. And if it's -1, it shouldn't ever be -1. Because I'm no longer going to be moving them. I'm now going to be just having them go straight in, and it's going to be fine. So this should yeah, it should not be -1, should not be less than -1. We should just be able to get the index and then just stuff it into the appropriate spot. This one, this is all we care about. So we're just gonna stuff the game, like sort of the game object, into the cells at Y index and X index, and then the game object ID. Now we may have to assert that the Y index is actually inside this location, except I think we'll get an error if this doesn't work. So if we do add here, and that's all we're doing, so we're just adding that in. Let me go ahead and not draw yet. I'm just gonna add them and see if that code works without errors. Okay, so no errors, so I think that's good, but we need to like actually now draw these to the screen. So that's next. Drawing to the screen is, okay, so here's where it's gonna get interesting. I could just loop through all the cells, just like what we're doing here. And then for every game object, tell them to draw, and not the ones off screen to the left, because those don't exist anymore. Let's see if this draws everything. It does. Okay, so that works just fine. Now, here's a problem. I'm drawing all the stuff off to the world to the right, even though it's off screen. So this is where I really want to do a query. Get the, this is where the camera comes in. I want the camera to query the grid for everything that's within like that certain size. And then draw that. So let's add in a query here. So we're gonna query like get, I wonder if I can just do this as a getter too. So we want to get cell, like get game objects in range, I guess. And we're gonna have the X and then the Y. These is gonna have to be the X and the Y that the grid knows about. So the world coordinates as opposed to the camera coordinates. And then we're going to do a query and the return. Oh, so we need the X and the Y. So like this is gonna be the start X, maybe. Oh, we can just do X and Y. Do the same thing as a rectangle. And then we'll have the width and the height. There we go. Everything that is within there, all those cells, will then return an array of their objects. And of course, it'll just be a reference to those objects. But since they're objects, it won't matter. We don't have to do anything special. It's JavaScript. Okay, so get game objects in range. So if we pass it like 0 to the camera width, because that's where we're going to start, what would we end up doing here? We need to, let's see, if this is pixel coordinates, I need to convert this to what the starting index is. The starting index is what the end. Okay, yeah. So what the starting index is. So let's see. It's like index x equals. This is going to be the x. Actually, math dot floor x divided by this dot cell width. That index y equals math dot floor y divided by this dot cell height. Then we need like the width and the height, right? So this, we need to turn this into like the number of cells that we're really going for here. And I think that's going to be the exact same calculation for this, for the count. So this is going to be let width equals, so we can shadow this, or maybe this could be like width count, maybe even x count equals math dot this dot cell width. Okay, at y. Okay, so I think we now have indexes, like basically grid coordinates for where to go. We have index of y, index of x. This is where we're going to start with. And then we want to loop through each of those and grab everything that we need inside of them. So what I think this is going to be, and if we go back to our whiteboard here, what I think it's going to be is we're going to start with essentially like this point right here. So this will be like the x index and the y index will give us like this box. And then we have the x count. So we have the array going down. So starting with like this array, loop through for this number of times and give me everything that's in here, and then add that to an array. And then of course, reset the x index, the x count. I guess we're gonna have to have like one more variable for like the loop, and then come back to here and then go down and do the exact same thing. That's what we're gonna have to do. So this is going to be another double loop, and also means we're going to need our const, essentially our like the game objects in range here. So we'll call this just game objects, and we'll have this be an array that we're going to build out here. So we're going to start doing a for loop. So for let, now we have this index x, index y. Kind of want to make this a cell index x
Or maybe we could just leave this here and now call this one cell index. So cell index y equals, and I'm going to start with index y here. And we're going to continue looping until cell index y is less than, we have to go through the entire height of this. So like how many do we have? So that's going to be this dot cells. Actually, it's going to be this dot height. This specific height here. And I don't know if if I need to do less than or equal to. It really depends upon what this number coming in is and what like my math.floor ends up getting me. I'm thinking I might have to do less than or equals. If I get an error that I'm out of range inside of the loop, that will definitely tell me. And then cell index y plus equals to 1. Okay, so that's our sort of looping through down. Now we want to loop through each x index, so the exact same thing. Okay. I should now be able to get everything that is in here that I have access to should be whatever we want to display inside of the camera. So I should just take all these things and throw them into the game objects. So we need one more loop, which is to loop through the object that is the cell. So we're going to do a for in loop. This is going to be the ID. So light ID. It's technically going to be the game object ID in. And now this is where it's going to be interesting. So this dot cells of position cell index y, and of that position cell index x, and that's it. Now we have the game object ID. Let's throw the value of that into game objects. And this is going to be, well, this exact same thing again. And the very end here, game object ID. Well, that's fun. And then down here at the bottom, we're going to return game objects. So every frame, shouldn't those loops be bounded by less than or equal to index of y plus y count and less than or equal to index x plus s count? Wait, this one. Oh, I'm not using y count. You're right. I'm missing that up. Hold on. So we have, I'm using this. Yeah, this should be the y count. You're right. You're exactly right. So we should start with a cell index of x. Cell index of y in this case, plus y count. All right, thank you for catching that, Uspi. Even though like VS Code is trying to tell me, hey, you're not using me. You should probably use me. Cell index x plus x count. Okay. Well, that's definitely interesting how Prettier just refactored this one. But now we have our get game objects in range. I believe that we should now be able to actually run this and like figure out what we want to. So maybe before we add everything in, let's not change anything else. We have that that variable. This is one of the nice. Grid is not defined. Oh, getter functions must have no arguments. Okay, then I'm not allowed to do that. This actually has to be get game objects in range. Okay, so here we have this. I can actually use this as this part of like this argument. So we can do grid dot get objects in range, and we're gonna set our range here. So if I want to do I guess like maybe just a couple of these, we can start with 0 pixel wise, and then let's see, the y would be 0, so starting here, and then the width I want to be, these are each like 50, so if I do maybe 50 width and what would this be, 500 height? Nothing? Like no return? Did I crash it? Apparently that was not very happy. Okay, let's stop that script. Let's try this again. Do I have an infinite loop or something? Let's put a breakpoint, a debugger object right in here. Then I'll run the exact same thing and we'll be able to start like actually seeing this. So we can see, okay, x count, we have x index is 0, y index y is 0, x count is 0. My mouse stopped working for a second. Did I lose frames? No? Okay, so my mouse just stopped working. I wonder if it's running low on battery. X count is 1, Y count is 10. Okay, so we want 1 to the right, and then 10 all the way down. And of course, game objects is empty. So let's go ahead and watch here. We want game objects, and sort of see this as it fills up. And let's start hopping over here. So we go through. And we're getting nothing. So we should get nothing for like the first several of these as it goes down. So we're at cell index. We're at cell index x6. Oh. Okay, I see. This is an infinite loop because this number is constantly increasing and becoming bigger and bigger. And of course it's saying, hey, are you ever smaller than yourself plus, 1? No? Okay, keep on going through the loop. Well, that's a problem. So we have an infinite loop here. So we don't want to use whatever it's coded for this. So this cell index y is a terrible idea. I think it has to be index y, or yeah, index y plus y count. Yeah. And then index x. There you go. I think that's going to be a lot better. Let's try running this again. Oh, did I freeze you? Stop. Okay, so running through this again. Okay, that went out of that loop a lot faster this time. So now our cell index y, the y's and the x's are incrementing and we're going through. We're at 4, 5. I think it's 7. Seven or 8 where we get, or maybe it's 9, I don't remember. Okay, so we found the game object ID, and now that's in here. Okay, so I should be able to return, come back to here, uncaught error, can access property 0, the cells index y is undefined, so I think I need to use less than instead of less than or equal to. But besides that, I think we're good. So I can now remove this debugger statement. Let's hit refresh on you. Here we get this array, and we get the one thing that's in here. If I change you to say I want everything between, so 0, 0 to maybe like, what is going to be the width of this? This is going to be, I forgot what that is. 1,500. So 1,500. And here's the 15. It has 15 objects in here. Is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, perfect. Okay, so now my query function is working correctly. Which means I can now have my camera. It's gonna query these, and then it's gonna run the updates for that. So let's actually go and start like working on the camera and getting the camera to run the draw, which means there doesn't need to be a draw method here. Like, we're gonna just get rid of this. The grid doesn't draw its stuff out. And so if we come back to game, we're not gonna run grid.draw. We're gonna have, okay, so we're creating our camera. Did I actually do anything with the camera? Okay, so camera equals new camera. Then it's gonna have its X. We should probably just give it its like X and Y location. It's like an X and a Y. So that would be 0 and 0, and then the width and the height of everything. That's gonna be here. Then down here, we're gonna want to draw. So the camera is gonna want to get access to the grid in order to query it and then draw it. So we're gonna do camera.draw, and we're gonna pass it the grid. And that's it. So let's go to our camera. So we're gonna have X. We can just set this. Okay, we believe that you're gonna be 0. Y, we believe you're gonna be 0. Let's not have a velocity to begin with. We're gonna have Did I even... Yeah, 0, 0, width and height. And so then the width and height. Okay, so this dot location is going to be a create vector of x and y. We're not going to have a velocity to begin with. This dot width and this dot height. Okay, perfect. Then we're going to have a draw method that's going to take in the grid. What are we going to do? We need to get that array of references to all the game objects. So we're going to call, let's see, const game objects to draw dot get it's you. Okay, so get game objects in range, and then we're going to pass in our location. So this dot location dot x, this dot location dot y, this dot width dot height. Now that we have this array of game objects, we're going to loop through them and then call draw on them. And so I think this is going to get us the exact same thing that we were doing before. And I believe that we were actually calling this already. So let's go ahead and run this. Excellent. So this is all exactly what we were sort of expecting to see. And if I change, if I, for example, say, hey, camera width, you're actually just 150, for example. It just now only shows us 150 pixels worth of stuff. So perfect, that's exactly what we wanted. So we now have a camera. That's pretty cool. That means that all of this stuff make you go away. All right, so we have a camera. Now, if I want to pan across the entire world, all I need to do is have the camera move to the right. Well, what is that going to look like? I guess like to the beginning, like at the beginning, we could give our camera a velocity. So let's in here, we'll give it a velocity. And our default velocity is going to be a create vector of 1 and 0. And then we're going to have an update method. It's not going to take anything in, and all we're going to do is say this dot location dot add. I do need to store this way. Okay, so now I should be able to run update on the camera, and everything should just sort of look like it's panning to the left, but the camera is really panning to the right. Oh, that's a problem. It is panning to the right, but sort of like the screen isn't moving with it. So that's fun. Now what do I need to do to get that to work? Oh, that's kind of like a fun sort of like visual effect as everything disappears. So we're not set to the camera. The camera is moving, and like we're just like still standing here, not following the camera. So we need to figure out a way to have us follow the camera. And what that means is when we loop through these objects, are we... I want to say that we're still getting everything. So I want to console.log the game objects. I want to say that we're still seeing these. And then as we reach the end of the level, we get less and less of them. It's like 13, 14, like 15, 16, 17 of them. 18, 17, okay, it's going down as it reaches the end of the level now. Okay, so I think that's working. What I need to do is I need to now tell the camera, I want you to draw all these things in the camera position, as opposed to, let's go ahead and remove you and make you not do that anymore. The camera position as opposed to the world position. Don't draw in a world position. And that means that we need to like offset it. So when I tell GameObject to draw, I probably also need to tell it like an offset. So as the camera goes to the right, let's go back to our whiteboard and see how this is working. As the camera moves to the right, this one would normally be drawn over here because it's second over. So I need to tell it, hey, even though you're 50 pixels over here, I want you to start at the very left edge. So we know your position is going to be 50, x 50, and then y 400, I guess. Or 450, maybe. Okay, yeah, 4. So this is x50, y400 down. I need to shift it and translate it over. And tell it, hey, you need to be on the left-hand edge of the screen, as opposed to like stay in this, this spot, one over to the left. So we know your x and the y, and we know the camera's x and the y, and we need to do a little bit of math to translate it. Now who's going to do the translating? Probably the game object. When I call draw, I can pass in what it is. Or game object won't have anything at all. As you mentioned yesterday, this is where P5's translate function is useful. You just need to push the render state, translate by the camera position, draw everything, and then pop the render state. Ooh, okay, so let's try that. And I think let's go find that documentation. So translate. Oh, interesting. Okay, so it doesn't show the pop. Oh, no, here it is. If translate is called within draw, the transformation is reset when the loop begins again. This function can be further controlled by using push and pop. Okay, so what is push? So start a new drawing state. Then we sort of do that. And then restore original state. So we're going to push... translate everything. Oh, interesting. Okay, so start a new drawing state. So push. they draw this ellipse here, push again, draw the next ellipse. So left middle circle, right middle circle, pop, pop. Okay, so circle, push, draw a circle. I guess it's not like translate here, but I can sort of like use those together. So what would this be? Would it be for each one I push and then I pop for each one? Let's see, you need to push the render state, translate by the camera position, draw everything, then pop the render state. Oh, okay. Just one translate for the entire batch. Okay, so that means only one push and pop too. So if I do in here, that would be we have a push, and then down here we have a pop. Now for each of these, we need to then translate. Translate is that X and Y, that's it? Okay, X, Y, and potentially 0. So it's just gonna be like moving over by the amount that we have. So this is gonna be this dot location dot X, this dot location dot Y. We don't have a Z because we're not 3D. And then draw everything and then pop. And I don't know if I need to like push and pop for each one. We'll see. Let's see what this does. Well, that's cool. Not exactly what I was hoping for. We move backwards. It might need those as negatives. I think I do, because I'm moving backwards. So let's not close that. Let's do this. This needs to be negative. There we go. And our camera is now moving negative X, which would think like that. One would think that the camera is moving like this. Or I guess like for your position, it'd be moving like this. But everything else is moving to the right, so I guess that works. However, I'm super happy because it works. So thank you so much, Utsby. This is really awesome. Now, out of curiosity, what happens if I don't put the push and pop in? Because it says it like resets every single draw cycle through, and I'm not really doing anything else at this point in time. Like everything works just the same without the push and the pop. It's the translate that really does it. Now, if I do draw anything else that's not in the camera, I think I would need the push and pop to make sure we're in a new state. So this is probably a good idea to keep in here. I just don't think it's absolutely necessary right this second, but it probably will be nice to have later. So this is nice and awesome. We now have a camera that is scrolling past the entire level. Okay, so that's perfect. Yes, it'll be okay here, but if you introduce other render stages, then it would be an issue. Absolutely, yes. Thank you. So we reached the end of the level. Now, right now, the reason why we have, well, we should now, you notice how everything is like super smooth now. And that's because we're not running into the exact same problem. Interesting. Notice how our our level is sort of like pulling things in and they're sort of appearing on the right, we need to query for things farther to the right than what we really are. So let's do this. So we want this dot width plus, let's just do game data dot cell size, just to make sure that we're getting just a little bit extra information. And now it's going to be super smooth the entire way. And so now we can see our entire level as we're going through it. So this is nice and fun. All right, so what I really want is a player, and then we're gonna have the player do its update, and then the camera is gonna update itself based upon the player. Of course, the player is gonna be a game object in here. So let's go ahead and add our player in. So inside of player, we know that we have the start here. That's where we're gonna put our player. We also know we're probably going to want a draw module too. So we have this draw module, do a class draw player. This color equals color. I think we'll just do white for the player right now. Okay, so we're gonna have the location, the width, and the height. So here's where we get to like have our fun player. Let's make sure that for our draw player, we want, let's see, what is this gonna be? Previously, we just sort of like, I think a circle and like a body on top of it. So if I do this exact same thing, I'm gonna do a fill, this dot color. If we do a circle for like the head, so that's an ellipse. This dot location dot 0 dot x. This dot location y. Then I guess like the radius is just going to be this dot width. So that will be a circle. I probably don't want. Well, that's gonna be interesting. Like how we're gonna like store what the player looks like. If I do this to begin with, we'll see what this ends up looking like. Now we also want a rectangle. So this is gonna be a rect. This dot location dot x plus like whatever the body is. So we probably want like the player, like maybe in the game data to store like the player information. So if we have like player and that's an object, then we can have something like head size is maybe, let's see, 50 is like an entire world unit. That seems like maybe a pretty big head size. So let's make it like maybe 20, 25, half. And body height could be an entire world size. We can just make this 50. And then body width is going to be maybe half, so like 25. Now I can actually reach in here and grab these inside of our draw module. Let's go ahead and pull this in here. Okay, so for our ellipse, we're gonna have the location.x and the location.y. So it's like center mass, but we need to probably, well, if we do the top left of the player, now also, do I want my player to be all encapsulated inside of one sort of unit of size? I might want that, which in that case, let's sort of change these numbers around. Our body height should be probably like half of this cell size. So I can do something like 25. You can do like 30. Our head size is gonna be 20. We can try this. We'll see what it looks like. Okay, so this dot location. If we start with like, I don't know if I want to do like the center of the player for this. So it's going to be like the left edge, maybe like the body. We figure out like the body is all that really matters, right? And its head is just displayed above it. But we don't really care about that. Ooh, in that case, the body height can be 50. Okay, that will work. All right, let's try this. The body height is 50, so that means I want to take this at location.x, and if I want this to be like the top left of the rectangle of it, let's do the rectangle first. So this dot location.x and this dot location.y is the body, and then we have our width, so that's going to be width and height, sort of like passed into this. There's no this on here. It's just everything that's passed in here. And so that gives us our rectangle. Now the head location, we're gonna have to take the location.x, which is the upper left corner. We have to translate that into the middle of the body. So that's gonna be location.x plus game data dot player dot I guess in this case it's just gonna be the width, right? So width divided by 2. That's the x. The y we have to subtract a little bit. So this is gonna be location.y minus, and here's where my head size comes in. So it's gonna be game data okay, so game data dot player dot head size divided by 2. So that moves it like halfway up. So shift it over into the middle, halfway up. And then our width for this, because it's a circle, we only need one of these, and that's going to be the player head size. So game data dot player dot head size. Okay. That should be our player. If I don't like actually have it the ability to move at this point in time, that should be fine. So we're gonna come back into game. Let's create our player. So in our start, we want to put our player in here as well. So that's going to be right here. So we've created the floor, we've created a little start area. Let's do const player equals new game object. Okay, so then it's going to be the next object ID. Then I think it's the X location. So I think this is going to be the same here. What are you? That is the... Oh, this is the cell size for like the start. So we actually have the width is in game data. We have the player body height and a body width. So game data dot player dot body width. Okay, the height, and then the drawing. So this is going to be a new draw. What did I call this? Draw player. And can't forget, we want to do next object ID plus equals to 1 grid dot add player. So if nothing else, there's our player. Now, our player I think is over the grid start, isn't it? Yeah, because I think our start is like right there. So our X and Y position is maybe a little bit off. So I don't want it exactly like this. Okay, so we have the X and the Y in the grid. Let's just put it at the beginning. So X and Y. Let's try you. Oh, I definitely do want you to be up on top of the ground. So Y is minus game data dot cell size. There we go. There's our player right next to the start screen. Oh, don't want to save. So anyways, that looks pretty nice. I then want to lock the camera to the player's position plus maybe like 4 units in, so that the camera is always, doesn't have the player at the very left. And I don't want it like at the complete center either. Although that could be interesting. So let's go ahead and figure that out next. Now the player... when I create the camera, we have this velocity that's like 1, 0. I kind of want you to be 0, 0 by default. That will make you stop moving. When we update the player, when we update the camera, we need to somehow attach the camera into like the player to make the camera like be able to update its X and Y coordinates with that. Now with the game here, I am creating like the player inside of the start. I don't know if I really want to do this for real. It might be better for me to do this outside of this entire like build level, as it were. And that would allow me to do this up here. I would have the camera, and then I can pass in maybe like a reference to the player to the camera, and the camera can just sort of be aware of the player. And is that how I want it to work? Because when I update the player with like I give it like an update module, or I give like the player an initial like velocity moving forward, I want the camera to follow the player. So what would that end up looking like? We need the camera to zero in on the player, so we need to create the player up here. So I'm going to take you out of here, save you, put you up here. Okay, so here's this player. Now we have next object ID. That's fine. I think starting with 0. Oh no. Your plus equals to 1. Are you ever set? You need to be set up here. Now, okay, so this X and Y. So where are we going to start? Well, we need to start like 3, I think, over. So that's going to be 3 times game data dot, like wherever that start is. So maybe we can do like player start. Here, we can have like the start. So start X. We know we want this to be 50 times 1 or 0, 1, 2. So that would be 100. Start Y is going to be 50 times like the height. So it's actually going to be, I think, 350. Okay, so we have the start Y, we give it the body width and the body height, and then we tell it to draw the new player. And then we need to add this player into the grid. So here's this grid add player. We increment the next object ID, and then we create the camera. We say what its initial positioning is going to be. So it's like X and Y, and its width and its height. I think that's gonna be fine for right now. I kind of want to like already set it with the player, right? So to say I want this to be, its X is gonna be the player dot location dot X, maybe minus several games sizes. That's what game data dot cell size times like 3, and our height is 0. So like start up there at the top, then the width and height of the screen. Okay. I think that will set us up for success here, or not. What did I miss? Can access property add grid is undefined. Oh, right, because grid is created down here. So we need to create the grid first. So there we go. Here's our player. And we can see now the level is actually starting over here. I can actually have the player center on the camera center on the player by just doing, what if we start with the player location.x? Oh, that sets us over here. So that would be minus the entire width divided by 2. There, now that like sets us centered with the player. So we can like basically play around with this and say, hey, what if we just like make it a quarter of the way over? There's our player and there's our world moving off the left. So that's actually perfect. I really like this. Now we have the ability to sort of like move this player around based upon the camera. So if I want to update the camera, I need to not necessarily give the camera a velocity, but to reset the camera's like X position based upon the player's X position, which is going to be a little bit interesting because the player is now just sitting there inside of the game objects. We don't have access to it. Now we can do some fun like things with object-oriented programming, but I'm also trying to think about not passing everything around by reference, if possible. At least like not going too deep into the entire reference, like, everything else. But that sounds to me like maybe a tomorrow problem, because it is past 8:15. So here's like a really quick recap of what we did. We created a camera. We gave it its entire like sort of initial setup of where it is, and then we're going to have it query the grid. The grid takes in, for part of this query, the x, y, and width and height coordinates, figures that out in grid coordinates, and then basically returns an array of all the game objects that are within that sort of camera view. The camera takes that array, translates itself over, translates the entire world by itself, and then draws all of the game objects. And then it just sort of repeats that for the entire, as everything is going along. I can move the camera independently, but right now I don't have that happening. So instead, we're gonna have to figure out next time how to get the player to move, which should be pretty simple. We'll give the player a velocity of moving to the right. And then I want to have the camera follow the player, which means the camera needs to know that it's looking at the player when it does its update. So that will be a little bit interesting. But as I said, that sounds like a tomorrow problem. So with that, and here, so add an